Hey, welcome back. This is the third video in this series. So far we've introduced the endocrine system, we've introduced hormones, and we're specifically trying to relate them to the 2015 MCAT foundational concept number 3. And that's dealing with the body's ability to achieve and maintain homeostasis. So if you're starting here, you're not really sure about what the endocrine system is, where its organs are located, what a hormone is, I definitely encourage you to check out those first couple videos. I think having the big picture ideas is going to make going deeper today, a little bit less daunting. So without further ado, we've been talking about the endocrine system as this really fascinating system of organs that signal feedback information between different parts of the body. So today we're going to talk about some of those organs individually. And we're going to start with the hypothalamus and the pituitary gland. And so if you recall right here on our boy Leo's Vitruvian Man, this reddish-orange structure in the middle part of the brain here, that's the hypothalamus, and then dangling right below it is the pituitary gland. But it's kind of hard to distinguish there, so I'm going to show you a little bit closer up picture here that I think is going to kind of clarify this structure a little bit better. So again, right here, that middle part structure in the brain is the hypothalamus. And then dangling right beneath it is the pituitary. And then I further enlarged that in kind of my hand-drawn image here. And so this is the hypothalamus up here, kind of forming this neck down to the pituitary gland, which splits between the front or the anterior aspect and the back or the posterior aspect. And so as the brain signals the hypothalamus through nerves up here, it in turn signals the anterior or the posterior pituitary gland to affect a change in the body. So let's talk about the hypothalamus and the anterior pituitary and how they interact. The hypothalamus interacts with the anterior pituitary through paracrine signals. Remember, those are the signals whose receptors are close to the site of production. And so the anterior pituitary is where these receptors are located, and they're really close to the site of production in the hypothalamus. And so those signals are going to cause the anterior pituitary to in turn release its endocrine signals. And remember, those are the signals whose function is at a distance. So the anterior pituitary signals are the ones that are going to travel throughout the body to affect a change in different parts and in different endocrine organs. So the hypothalamus releases GnRH, or gonadotropin releasing hormone, which stimulates the anterior pituitary to release follicle-stimulating hormone and luteinizing hormone. And both of those anterior hormones are going to stimulate the gonads to produce their hormones like estrogen and progesterone and testosterone. So they're going all the way down to the gonads. The hypothalamus also releases corticotrophin releasing hormone, or CRF. And CRF stimulates the production of adrenocorticotrophic hormone, or ACTH. And ACTH goes from the anterior pituitary down to the adrenals, and it stimulates the adrenal glands. So the hypothalamus, continuing on in that relationship, that the hypothalamus secretes thyroid releasing hormone, which stimulates the production of thyroid stimulating hormone by the anterior pituitary, and that's going to go down to the thyroid gland to stimulate the thyroid gland to release its hormones. Prolactin and inhibitory factor is a hormone that the hypothalamus releases, and it functions a little bit differently in that really it's kind of always churning out this PIF. And when it stops churning that PIF, when the anterior pituitary stops receiving that signal, that's when the anterior pituitary is going to release prolactin. And prolactin is a hormone that is involved in milk production, in mothers. So, and then moving down, we've got growth hormone. And so growth hormone releasing hormone by the hypothalamus, that's kind of a funny one. Growth hormone releasing hormone, go figure, causes the release of growth hormone from the anterior pituitary gland. And it may take pausing the video to really let that vocabulary sink in a little bit, but it's pretty intuitive. I almost said intuitary. Been talking about the pituitary so long, but it's pretty intuitive. And so anyway, the mnemonic flat peg might help you remember those anterior pituitary hormones a little bit easier. And so the flat ones, or FLAT, so FSH, LH, ACTH, and TSH. Those are tropic hormones, and what tropic means is that they're stimulating the production of hormones by other endocrine glands. So you remember the F and the L, they're going down to the gonads to stimulate the gonads. The ACTH is moving to the adrenal glands, and T is stimulating the thyroid gland. And so the flat ones are tropic. PEG, on the other hand, those are direct hormones. So P is the prolactin and G is the growth hormone, and those are actually going down and directly affecting the different parts of the body. Growth hormone is affecting long bones and other aspects of growth, and prolactin is stimulating milk production. And then E, I skipped it earlier because it's produced by both the anterior pituitary and the hypothalamus. It's not part of that kind of that cycle between the two, but it's endorphins, and endorphins are hormones that alter our perception of pain. But flat PEG sticks in my head and kind of helps me remember those anterior pituitary hormones. So what about the hypothalamus's relationship with the posterior pituitary? Well, it turns out that the posterior pituitary actually stores hormones that are made by the hypothalamus. So it's not making these hormones, it's storing them, and it's releasing those hormones when it's stimulated through the nerves by the hypothalamus. So those nerves are running down the pituitary stalk, and they're stimulating the posterior pituitary to release the hypothalamus's hormones. And so those hormones include ADH, whose function is to alter fluid volume in the circulatory system. That's antidiuretic hormone. And oxytocin, which oxytocin is involved in stimulating uterine contractions in the labor process, and then kind of subsequently also, I believe it has an effect in milk production in mommies. So anyway, the hypothalamus and the pituitary gland can be super intimidating, but if you can develop a big picture for how they work together to control the endocrine organs, I mean, I really think that you can make sense of them. So let's go back up to the Vitruvian man and think about the pituitary in a bigger picture. You see this little gland right here in the brain, and how it might affect the thyroid gland and alter the body's metabolism. And it might send out ACTH, which goes down to the adrenal glands to kick in and ultimately change fluid volumes in the blood vessels. And as crazy and as long as those names get for all those different hormones, I want you to be able to see that it all just centers around one part of the body communicating with another part of the body through chemical messages called hormones. And that's what the endocrine system is. So anyway, one last topic, I've got a couple more minutes that I want to explore, is a negative feedback loop. And I think it's a really good idea to discuss here because it's key in understanding how the control center knows when to stimulate the body and when not to. And so I just want to go through one example so we can see how, blood hormone levels are regulated, and then you can practice using different hormones until you get more comfortable. But I mentioned before that the hypothalamus releases corticotrophin releasing hormone, or CRH, and that stimulates the anterior pituitary to release ACTH. And then that kicks the adrenal glands into action and causes it to release one of its hormones, let's say cortisol, which you'll learn about soon. But how do the adrenal glands know when to stop manufacturing cortisol? Well, it turns out that the hypothalamus and the pituitary glands both contain receptors that respond to rising cortisol levels by stopping the production of its initiating hormones, CRH and ACTH. And this is the basic premise of a negative feedback loop, that it's actually the abundance of hormones that causes a decrease in the production of them. So it's the ability to reason through a negative feedback loop and to think critically about hormone levels in regards to the pituitary gland that I really believe is important. And I think it's much more important than just memorizing each hormone name. So definitely try to spend some time practicing here and developing a comfort with the idea of how a negative feedback loop operates. So anyway, I'm definitely out of time, but I hope I've shed a little bit of light on the control center of the endocrine system, and maybe in future videos we can get after another endocrine gland, and I will see you there.